Today we're going to review multiplying decimals. Here we have 1 and 42 hundredths times 2 and 7 tenths. First, I'm going to rewrite my problem vertically, lining up my digits just as if I were multiplying 142 times 27. As a matter of fact, I'm going to completely ignore my decimals in this problem and work this problem just like a 3-digit times 2-digit problem. So, 7 times 2 is 14. Put my 4, carry my 1. 7 times 4 is 28, plus 1 is 29. And 7 times 1 is 7, plus 2 is 9. I'm going to go ahead and cross out these up top. I'm going to put a 0 in as my placeholder because I'll be multiplying by the 2 now. And so my next partial product will start under the 2. Here I have 2 times 2 is 4. 2 times 4 is 8. And 2 times 1 is 2. Now I'm going to add up my partial products. 4 plus 0 is 4. 9 plus 4 is 13. Carry the 1. 9 plus 8 plus 1 is 18. Carry the 1. And 1 plus 2 is 3. Now, with multiplying decimals, I need to go back and count how many digits in the problem are behind each decimal. I have a decimal here, and after that decimal I have a 4 and a 2. I have a decimal here, and after that decimal I have a 7. So I have 3 digits. The 4, the 2, and the 7 are all after decimal points in the problem. So because I have 3 digits after the decimals in my problem, I have to have 3 digits after the decimal in my answer. So my answer is 3 and 834 thousandths. Let's take a look at our next problem. Here I have 3 and 6 tenths times 14. So I'm going to put my 3 and 6 tenths times 14, lining up my digits. And again, I'm going to work this problem just as if it were 36 times 14. 4 times 6 is 24. 4 times 3 is 12, plus 2 is 14. I'm going to cross out that 2. I'm going to put a 0 to hold my place. And I'm going to multiply 1 times 6, which is 6, and 1 times 3, which is 3. Now I'm going to add up my partial products. 4 plus 0 is 4. 4 plus 6 is 10. 0, carry my 1. And 3 plus 1 and 1 is 5. Again, I have 1 digit after the decimal here, and the 14 didn't have a decimal. So in my entire problem, I have 1 decimal and 1 digit after that decimal. So in my answer, I need 1 digit after the decimal, and my decimal belongs right here. My answer then is 50 and 4 tenths. Let's take a look at the next problem. Here I have 3 and 25 hundredths times 7 tenths. I'm going to multiply 7 times 5, which is 35. 7 times 2 is 14, plus 3 is 17. And 7 times 3 is 21, plus 1 is 22. Now this 0, I could put a 0 to hold my place and multiply by that 0, which 0 times 5 would be 0, 0 times 2 would be 0, 0 times 3 would be 0, and then I could add all of that together, and it's just going to be adding zeros. So because that 0 is at the beginning of my number, I can really just ignore it and know that it's not going to make any difference in my answer. But here I have 2 digits after the decimal and 1 digit after the decimal. So in my answer, I need 3 digits after the decimal, which is going to make my answer 2 and 275 thousandths. Let's take a look at our last problem. This one looks difficult because it has 3 digits times 3 digits. But remember, in this bottom number, the 0 in front really doesn't make any difference. It would really just be adding zeros. So this is really a 3-digit by 2-digit problem. Now, 9 times 4 is 36. So I'm going to put my 6, carry my 3. 4 times 0 is 0, plus 3 is 3. Many kids make mistakes with that 0. 4 times 4 is 16. I'm finished with that 3, and because I've multiplied using the 4, I need to put a 0 as a placeholder because now I'm going to use the 3. And again, my partial product needs to start in the column under that 3. 3 times 9 is 27. Again, 3 times 0 is 0, plus 2 is 2. And 3 times 4 is 12. Now I want to add. Remember, I could just not even think about that 0. 6 plus 0 is 6. 7 plus 3 is 10. 0, carry the 1. 6 plus 2 plus 1 is 9. 1 plus 2 is 3. And nothing plus 1 is 1. Again, I have 1, 2, 3, 4 digits after the decimal. So I want 1, 2, 3, 4 digits after the decimal in my answer. And my final answer for this problem is 1 and 3,906 ten-thousandths. I hope you learned a little bit more about multiplying with decimals. Have fun.